to the week 1 gradient descent video, which is part of the Intel Deep Learning course. And today guys, you're going to be learning it with me. It's important to know that this is a starter task though, and you also get yourself a project, which is very handy. We'll start by installing the preliminary packages. So in this case, this would be NumPy, Pandas, Matplot, and also sklearn. As you can see, we have installed the packages. We then activate this task though, which is to generate the data from a known distribution. So as it's giving us the model basically, and then we go to the next one, which is the random seed, and this helps us ensure we get the same data if all the other parameters remain fixed. Now with the random seed, it's highly possible to change these metrics as well, but you might get a different answer. So now with the exercise part though, we'll start by solving the problem. So we use linear regression, which is quite an important concept in machine learning. And whilst universities do mention it though, students don't really tend to understand what linear regression is, and it also has different uses in machine learning. But in this case, once the linear regression from sklearn is activated, it gives us out the array. Then we'll have to solve it by using a matrix calculation, and this gives us an array. You can observe how it's basically similar to the array over here. Now in this case, we're solving the solution by gradient descent, which is another way to solve this problem, is to use the method of gradient descent. We'll export this method because, as we will see, neural networks are trained by gradient descent. Seeing how gradient descent works on a simple example gives us the understanding, and we also have the stochastic gradient descent, which is basically another type of gradient descent, which is much more faster, and it's better basically for handling larger data sets, although it does have its own weaknesses, such as noisy updates and the fact that you have to tune it a lot of the times though. You can also play with these parameters. Now, as I observed, if you actually change the learning rate, you'll see that the graph over here, right now, it's smooth, it's efficient, that's fantastic. But if you change the learning rate, usually it will become far more squigglier, and that means it's too high, and that's not really good. You kind of want to balance them out as well. Now with this stochastic gradient descent, so this one's great with more larger data sets though, more larger data points, and it's much faster. The difference with this one is that it uses one data point at a time. Again. So we'll start again. As you can see, it's the same point. This used to be 001. I changed it to 008. And what it happens now is that it causes the lines to be more wriggly and sort of unclean. This means that it's way too high, and yeah, it's not really working out very well. However, if we change this to 01 and we run the program, again, this is done in the notebooks, so it's like a slightly different design. You should see it kind of changed. It's slightly different, basically. And if we changed it to, let's try changing it to something extremely high. Again, we'll have to run all of these blocks. Again, yeah, it's kind of dropped down basically. So yeah, so this was the gradient descent and the stochastic descent for the machine learning pathway. I hope you enjoyed this video. I hope you learned something new, and please feel free to ask us questions down in the comments below. Thank you very much for watching this video.